Hey guys, so in this video we are going to um, prove the distance formula for the distance between 2 points on a coordinate plane. So let's get started. Let me zoom in so we can get a close view. As you see here, it's a coordinate plane. I'm going to quadrant 1. Let me mark some 2 points. One here and one right. Okay. Now, example, let's say the coordinates of this one is x1 comma y1 and this one is x2. Okay, so as I said that, okay, now, so if we draw a straight line from one of these coordinates, so first of all, let's see what is the distance formula. The distance formula is d equals to under the square root of x2 minus x1 whole square plus this is 2 in the square root, I mean under the square root. I just don't have space to write it. Okay. So now, as I said that, let's zoom in here again. Okay, so now, as it says right there, let's take away this. So now we have 2 points. Okay, we have 2 points. So if we take a third point, which is on the same like we need to take a third point that has the same coordinates as one. It takes one coordinate from each point. For example, let's say this one is 6 comma, wait a minute, example, this one is 6 comma 1, this one is 7 comma 5. Okay, so what happens here is, if you look, these two are on the same line, so they must have the same same y coordinate, because the line is parallel to the x-axis, so they should have the same y coordinate. So this must be fine. And here it is the opposite, so it is parallel to the y-axis, so the x coordinate must be the same. So this must be 6 comma 5, right? So what they are asking us to find here is this distance. And always remember, distance can be any way. Like, you can take even long part. For example, you can take this. So here, what by distance they mean displacement. What displacement is the shortest distance between 2 points. Okay, so there are many ways to distance, but there is only one way to displacement. Okay, so let me clear this up. Okay, so now we have 3 points, right? 1, 2, 3. Let's just think the lines are not there because it's hard to write the lines. Okay, so as I said, Oh, wait a minute. Okay, so let's join these points. Okay, so we all know that x and y axis are perpendicular. So just now I said this is parallel. This line right here is parallel to the y-axis, and this line right there is parallel to the x-axis. So they must be perpendicular too. This must be right angle. Okay. So look here. As I said earlier, this takes the x coordinate of the first point and y coordinate of the second point, because I said they are parallel to the x and y axis respect, right? So this length is easy to find. The vertical length and the horizontal length is nothing but y2 minus y1, this one right here, cos for example, if you take, just think, so the y coordinate of this point is somewhere, let's think that is some number 6. Okay, I just rubbed the whole thing. Let's think some 6 is right here, 6, and this point in the y1 is 2. It's just the same way. So if you want to find the displacement, it's just 6 minus 2, which is 4. So the same things applies to this. So it's y2 minus y1, just this side, y2 minus y1, and the same thing applies to the other side, which is parallel to the x-axis, but this time it is x2 minus x1. Okay, it's just the same logic but different variables. So if you know, it's the same thing you do, but it's just switching those up. So now they asked us to find this distance, which is the displacement, as I said earlier, because distance can be in many ways, but displacement must be only one, right? So now, if you know the Pythagorean theorem, which states the states that if you have a right triangle, and for example, if A and B are the legs, and C is the hypotenuse, then A square plus B square equals to C square, right? And it's just a formula. So if you apply that here, look what happens. So let's think. Okay, let's think. Y2 minus y1 is the A right there. Okay, let's think y2 minus y1 equals to A, comma, x2 minus x1 is equals to B. So if we apply those now, let's do it here. Okay, if you apply those now in the formula, A square plus B square equals to C square. So what we need to find now is C, which is the displacement, right? So C equals to under the square root of A square plus B square. So what is A? This is A, and it must be squared, and the sum of this, right? Yeah, we are done. That's so. If you know, there is one more thing. This can be also written as x1 minus x2 whole square plus y1 minus y2 because, so as you know, when you square any digit it just becomes positive. So this is equals to this. So no matter what number you get or whatever you get, these both are the same value. So that's it. Yeah, that's it for now. Okay, please subscribe and like this video if you enjoy, and tell me if you found this helpful. Bye.